Hi guys, and welcome to Magic Cloud. My name is Thomas Hansen and I'm one of the magicians over at aista.com. And in this video, I'm going to be CRUDifying my database using Magic and Hyperlambda. And then afterwards, I'm going to walk you through the code that Magic automatically generated for me. Now, first things first, if you haven't already followed the setup tutorial where we set up Magic using the Docker images, then you might benefit from opening up the SQL menu item here and simply choosing the load button here and choose Aquila. Notice if you have already followed the previous video tutorial about how to set up Magic, you might probably already have done this. Anyways, I'm going to be executing this database script, and basically what the script does, it creates the Aquila database as published by Oracle that contains roughly 25 tables or something. And the database is intended to being an example rental movie database. When you're done executing, you need to purge your server-side cache. Click the little circle or icon here, empties your server-side database cache. Which point you will see now, you can select the Aquila database here. At this point, you can already select all from actor, for instance, and then click function F5 on a Mac or F5 on Windows, at which point you can select items from this table. Now, when we're done with that, we are going to go back to the dashboard. Then we're going to choose the CRUD menu item, generate CRUD apps. Click that icon, then choose the Aquila database and click CRUDify all tables. Yet again, if you followed the previous video tutorial, you've already probably done this, at which point you can skip this section. Anyways, I'm going to be generating now 3,325 lines of Hyperlambda code, as you can see. And now I can go back to my dashboard, open up HyperIDE and actually look at the code that Magic produced for me. Now, and of course, at this point, we can also invoke the endpoints and we can parameterize them, actor last name like, %, adds, invoke, at which point we're only getting actors whose last name starts with the character A, etc., etc. Now, you can also limit 2 records, for instance. You can do offset 5, and you can order according to last name if you want to, and you can order descendingly, and you can parameterize your endpoint invocations exactly as you see fit, including adding different operators in case you have multiple filter criteria, allowing you to change between and or type of criteria. Anyways, so what this video is specifically about is to analyzing the Hyperlambda code. So let's have a look at it. Hold down Option, click M or Alt M on Windows, at which point you maximize the code view editor. The top here you will see a .arguments collection. First things first, this is a node. And these are children nodes. They're nodes too, but they're children of this node in particular. This arguments collection is actually the declaration of which arguments my HTTP endpoint can legally be given. If I demaximize this window again, and you notice I have some 810 arguments here, you will notice the similarity between the names of these guys and the names of the arguments I can provide to my endpoint invocation. If I now, for instance, delete these guys and I save the file, Option S or Alt S on Windows, and I invoke it again, you will see I only have 4 arguments. And now, of course, I can do Control Z on Windows or Command Z on Mac to undo my deletion of this particular code snippet, at which point I can save the file again and I have all my arguments back again. So, and I can also explicitly add, for instance, foo, date argument. Save my file, invoke it, at which point you all of a sudden see I have a foo argument, and the front end actually recognizes this as date time argument, allowing me to actually choose which date I want to supply to this particular argument using a datetime picker. So those are some nifty candies related to your consumption of Magic Cloud and particularly its front-end parts. Anyways, so that was the arguments collection. Then you see a description here. This is just a friendly description, and this part is actually returned by the metadata retriever. So you can see here, returns items from your actor table, returns items from your actor table, right? So obviously there's a correlation between this particular dot description node's value and the description that the argument, that the endpoint shows in its metadata information. Then you see .type equals CRUD-read here, which is important, especially when we start CRUDifying and generating front ends, because the front end scaffolding parts of Magic will actually read this part in order to determine which type of endpoint this is and whether or not it should create a component for that particular file or not. Now here below that line you see auth.ticket.verify. Let me zoom in a little bit here for you if I can. Auth.ticket.verify root comma admin. That actually verifies that the user invoking this particular endpoint belongs to one of these two roles, root or admin. And in fact, I can verify that this actually is secure by copying the invocation URL here and opening up a Google Chrome incognito window, at which point my authorization header no longer exists in the client side of things, implying it will try to access this endpoint without an authentication JWT token whatsoever, at which point, of course, the system returns access denied for me. And actually, the system also produces a log entry for this particular invocation. As you can see here now, 14 seconds ago, access denied, and it also produces an entry in my health. If I go to security here now, you will see that I have one additional access denied being counted for on the 11th of January 2022. So if I remove this guy, I save the file, I open up the invoke, I copy the full invocation URL, and I paste it into a Google Chrome incognito window. Ta-da! Everything works. Why? Because now the endpoint is no longer having authorization requirements at all. Here is a validator. You can have a look at all the different validators that exists in Magic by holding down the function key, holding down the control key, and clicking space on a Mac or control space on Windows, at which point you're given autocomplete, and you can filter according to validators, dots, at which point you will see all the validators that exists in Magic. You have date, email, enum, integer, mandatory, regex, string, and URL. Now the most important parts of this file is actually further down here, where it invokes at line 58, if you're looking at actor.get.hl. It invokes data.read. And this part is actually possible for us to simply copy. If we start at the data.connect parts, we just copy this part, everything, copy it, then we open up a new browser window, go to localhost 5555 if you are using the Docker images, otherwise it's 4200, and then you open up the eval menu item and then paste in this particular code. At this point we can remove these guys because they're just actually decorating the data.read invocation with the values from our arguments collection, so we don't need to worry about them whatsoever for this particular invocation. And also, since our default database of choice happens to be MySQL, we can delete the database -type in both the data.connect and the data.read invocation here, at which point we're left with this, and we can click function F5 to execute this particular Hyperlambda, at which point we will see that it returns 25 records to us. And at this point we can remove this part too, because we have no where criteria, but we can exchange it with limit2, for instance, function F5, at which point you see you only get 2 records back. So basically what this slot does, it actually transpiles from its lambda, hyperlambda representation into a SQL statement, translates into an SQL data reader, which again returns everything as JSON back to the client. Now all of these parts are automatically taken care of by Magic, but basically now you understand the underlying theory and the foundation of how Magic actually does what it does. So let's close this window, and then let's have a look at the connection here, data.connect. As you can see here, it invokes data.connect with 2 square brackets surrounding a string being generic pipe Sakila. If we now open localhost :5555 and we go to the config parts here and we scroll a little bit down here, you will see in our database section here we have MySQL, obviously being MySQL. There's also one PostgreSQL and Microsoft SQL Server here. But we do have a key here whose name happens to be generic. Remember that guy? Generic. That basically means that this invocation to data.connect is actually referencing this connection string. And then it is replacing this part here with the parentheses saying database with this part. So basically this becomes a MySQL connection that opens up our Sakila database using this connection string. And then at the bottom here, of course, it invokes return dash nodes with an expression leading to the result of every single child node being the result of the invocation of our data.read invocation further up here, effectively ending up in that we get an array of JSON objects returned to the client as we invoke it, something you can see if you open up Google Inspect Chrome and you click its network tab and you invoke the endpoint. You can see here now we are getting a JSON array back if you look at the preview here, containing every single field in this particular database table. Now, this is the data.read slot. Why? Because we are invoking actor.get.hl. Now, the .get.hl parts here is actually kind of important. Why? Because .get implies that this Hyperlambda file needs to be invoked using the HTTP GET verb. And of course, the actor parts becomes its URL, and .hl simply means Hyperlambda. If you look at actor.post here, obviously, it's a post. HTTP post invocation, and posts are data.create invocations, meaning the C from CRUD. Put is data.updates from the CRUD acronym. Delete is delete, of course. So, and basically Magic creates 5 HTTP endpoints for every single table you have, and we can actually see this more easily if we delete this guy, and we can actually open up the CRUDify menu item from here, and then we can choose Aquila, and then instead of CRUDifying all tables, we can just CRUDify actor table, at which point now we only have the actor table, and as you can see here it generates an actor-count.get.hl, which basically just counts items, generates a delete that deletes actors, get that returns actors, post that creates actors, and put that updates actors. And this is basically the first database CRUDify Hyperlambda tutorial in our series. There's a link in the description of this YouTube video to where you can download Magic, and to an article also accompanying this article going slightly more into depth of what we actually just did now using Magic, in addition to a link to where you can download Magic. Thank you for watching. Have a nice day.